So this paper evolved a bit since we first named it. And so its title now is The Effect of Population Aging on Economic Growth, but we will, of course, address the issue of workforce aging. I'd like to acknowledge my co-authors, Kathleen Mullen and David Powell. David is right over here. So, as is well known to this crowd, the percent of the US population that is ages 60 and older has been rising and will continue to rise, perhaps even faster. But there is a tendency to talk about population aging as if it's something that's kind of off in the future, and albeit ever closer future, it seems. But in fact, the US population has been aging, in fact, almost monotonically increasing in the size of the population 60 plus, as far back as, in this picture, 1900. So here we're just showing the percent of the population 60 plus, and it's broken out into 4 older age group categories from 1900 through 2010, and then projections through to 2050. So it is indeed the case that the population, the older population, will grow more rapidly in the coming years, but it's actually grown quite a bit already. And the focus of this analysis is going to be the period of 1980 through 2010 to see what we can possibly learn that might give us some indication of what we might be in for in the future. So why do we care about population aging? Well, population aging relates very closely to growth in GDP per capita, which is a measure of living standards. So we care quite a bit. It is driven by growth in GDP per capita has essentially 2 components, productivity growth and labor force growth. Well, population aging affects growth in the labor force. Okay, so the first effect that we might be worried about is that aging would be expected to slow growth in the labor force, and this operates through what's called a declining support ratio. The support ratio is just the ratio of producers in an economy to consumers in the economy. Okay, so when your population is aging, your support ratio is declining. You have the number of producers growing more slowly. Can you not hear me? Was that a sign? I should be mic'd fine here. We're good? Okay. I can still wander, David. So the number of producers is simply growing more slowly than the number of consumers. Okay. So that's the first thing. The second thing is that, of course, aging may affect productivity growth, but now it's not clear exactly how this might come about. So, for example, there could be within individual changes in productivity with age. Okay. So a little bit of literature on this. We don't know a lot about it. But for example, it could be the case that an older workforce would be less productive if productivity falls with age. On the other hand, an older workforce could be more productive if there are large returns to experience. Okay? There could also be compositional change, and I think this is kind of a first-order effect, particularly for this analysis, whereby any change in productivity might depend on the relative productivity of outgoing cohorts to the labor force compared to the incoming workforce cohorts. Okay? Of course, aging strains entitlement programs. This could affect GDP per capita through the route of higher taxes and government debt financing. An aging population may shift demand for goods and services. It's another route by which we may have effects on GDP per capita. You can imagine we might have increased demand in certain service sectors like healthcare services, maybe reduced demand in other sectors. So you could have a shift in the age pattern in the composition of aggregate demand. There are a number of potential offsets, however, and these include longer work lives. That's the whole point of Kathleen's program. It can include further gains in productivity and even reduced consumption. It's largely an empirical question, I think, as to how all of these various forces play out in driving growth in GDP per capita and what the real scope is for these potential offsets to moderate some of these expected effects. Okay? Now, we actually have very little evidence on actual effects. We have a lot of predictions and some simulations, but very little evidence on what actually happens as a population ages, empirical evidence that is. And we start with this nice quote by Fair notes. This is a pretty understudied area in the empirical growth literature. Axel did a study in the mid-2000s simulating the effect of aging on the economy in Germany. This was a simulation study. And he noted, of course, that this declining support ratio would need to be offset by significant gains in productivity, for example. Fair looked at a cross-country analysis, and he found that the proportion of middle-aged workers, as that rose, productivity increased. Okay. Gary has noted that there is selective retirement of less educated workers out of the workforce, and that there has been a rise in the relative earnings of older workers compared to younger workers, and that this might suggest that an aging workforce is actually more productive, at least so far. Okay. There was a National Academies effort, and I think some of you may have been part of that panel. That I think it was led by Ron Lee, and they predicted that we would see a 0.5 percentage point reduction in the rate of annual growth in income per capita over the next 2 decades as a result of population aging. Again, another prediction not based upon any actual empirical evidence about effects so far. In their analysis, this slowing in growth of income per capita is primarily due to slowing labor force growth. They don't take a stand on, well, they take a stand, they expect there'll be very little slowing in productivity growth, or maybe even some, they acknowledge the possibility of an even increase in productivity growth due to aging, but they predict that the effect on productivity growth will be quite small. So our approach starts from the observation that across the United States, states themselves have aged at very different rates in recent decades. Okay? And in fact, these rates of aging are comparable to predicted future national rates. So we think there might be something to learn from studying what's happened so far using this cross-state variation in aging and its relationship to cross-state variation in the growth and output per worker, per population, sorry. So our approach is going to be to estimate this empirical relationship between population aging and economic growth using state-level variation between 1980 and 2010. And we're going to be looking at long changes, so decadal changes, because you want to abstract away from business cycle swings in GDP and GDP growth. So the rationale here will simply be that while state-level age structure changes may partially depend upon economic growth itself, okay, it's also a function of historical fertility, mortality, and migration patterns that, in some sense, are predetermined. So just to give you a flavor for growth for the variation in aging across US states. Here we're looking at the decadal change from 1980 to 1990, and this map is just, it's color-coded by the degree to which the state population is aging. So you see in California actually experienced a decline in the fraction of the population that was 60 plus during this decade. Nevada, on the other hand, experienced an increase of in the neighborhood of 5 to 15%. We've got them binned up. Wyoming saw very large growth in excess of 15% over that period. And there's Arizona down there experiencing growth in the range of 0 to 5%. So you can sort of you can sort of see the composition of changes. You see many states were actually seeing declines in growth during this decade. Many were seeing increases. That's a lot of nice variation in the effects of aging. Looking at the next decade, 1990 to 2000, this is an interesting period in which the baby boomers are still in their prime age years. And so they're swelling the denominator of these shares of older population and actually causing a decline in the percent of population 60 and over. And so you can see in almost all states there's a decline in the share of population that is older, although some notable increases scattered here and there. And now we look at the period 2000 to 2010, and actually I think indeed all states are experiencing growth in the older population. Very accelerated growth in the Pacific Northwest. California is experiencing 5 to 15% growth, and you see that kind of across the Midwest and into the Northeast. Concentrated high growth in the South area, in excess of 15%. So that gives you a flavor for the decadal changes in aging, in the rate of aging across states that we're going to be utilizing to identify changes in the growth rate of GDP per capita. We're going to use data from the BEA. We'll get state GDP there. We'll get employee compensation in a state also. We're going to use census data to get state-level age structure changes, and of course the American Community Survey for 2010. We'll also get labor earnings and industry composition of a state there too. So we start with a very simple causal model that would just simply relate the change in an economic outcome, Y, over a 10-year period in a state to change in the age structure, okay? And here we're looking at the log of the proportion A, that's 60 plus, okay, over that 10-year period, okay? The X vector includes industry composition variables. We're controlling for the pre-period industry composition in this model. And we also have base year dummies. But this is essentially just a very, very simple scheme for what you're trying to uncover with an exercise like this. The identification challenge, of course, is that economic growth may itself influence the state age structure. So you can, for example, imagine that areas that are experiencing slowing growth, perhaps slowing growth caused by population aging itself, that may in turn cause outmigration by prime age workers into other states, okay? And that's going to tend to exacerbate the effect on the age structure, making the effect of aging look a lot bigger than it otherwise is. So our strategy to deal with this is to find an approach that will shut down these migratory responses, as one example, to changes in GDP. And we're going to develop instead an instrumental variable strategy where we rely on the predictable component of aging in a state that's really arising from the state's initial age structure. And so an example would be to predict the number of 60-year-olds in, say, Alabama in the year 2000 by multiplying the number of 50-year-olds in that state in 1990 by the national ratio of 60 to 50-year-olds across across that 10-year period. Okay, so to kind of understand what this is sort of like a population Bartik instrument, or an instrument for a Bartik for population growth rather than for, say, employment growth. Okay. So this just formally writes out what I just explained, and the jumping down here. So at the top we have this predicted growth or predicted population age 60. And older is going to be a function of the total number of people 10 years before multiplied by the national growth rate for that cohort. We're going to do the same thing to get the denominator, or the actual population size itself. And then we can compute the instrument is simply this difference in predicted population 60 and up compared to the base rate 10 years earlier. Okay. So here's a series of pictures I'm going to show you of the first stage, if you will, relationship between the instrument, the predicted component of population, and actual population growth. Okay. This shows that relationship for the decade 1980 to 1990, and you can see we do get a very strong first stage relationship, and that point estimate, that slope coefficient, implies that for, say, a 10% increase in predicted population, 60 plus, you see a 5% increase in actual population. Looking at the next decade, 1990 to 2000, the relationship is a little bit less, a little attenuated, but still quite strong. 10% increase in the predicted population results in 4% actual. And same with the first stage relationship for 2000, 2010. Here we see a little bit of a stronger relationship. So we're going to estimate I'm going to focus on results where we estimate all decades together, but we want to kind of unpack for you what these relationships look like in the decadal changes.
Stanford, is that Louisiana? Like just the one that is.
That's, I don't know. David, you might remember. Yeah. That's good. Yeah. That's a good question. You broke the rules, Mark. Okay, so here's just the, if we just estimated that first equation without instrumenting, here's what you get. This is the OLS estimate of the percent increase in population 60 plus on the growth rate in output per person in a state. Okay, and we find a coefficient there, that minus 0.748. The way to interpret that is that a 10% increase in population share, 60 plus, leads to a 7.5% reduction in the growth rate of GDP. Okay, so a slowing of growth, a modest slowing of growth. Okay, now when we instrument, okay, just keep your focus on the blue boxes. There's a lot of other stuff in here. But in the interest of time, we'll just focus on kind of the higher level stuff. When you instrument using our predicted growth in population, you get a smaller effect, as would be expected if there were the sorts of migration patterns affecting actually, or these kind of reverse causality from GDP growth affecting the age structure in a state itself. And there the estimate now would be a 10% increase in population, leading to a 5.7% reduction in the growth rate of GDP per capita. Okay. Now, this 5.7%, we can, of course, decompose that into the component that's due to productivity versus the component due to workforce growth. Okay, so back to that first relation that I started with. And here, for this period, we decompose that 5.7% reduction in growth into the productivity component and the labor force component. So focusing on the productivity component, when we relate the growth in population, okay, instrumenting as before, to the change in GDP per worker, so the change in productivity growth using the conventional measure, we find a 4% reduction, okay, in GDP growth, in GDP per worker growth, so a 4% reduction in productivity growth, okay. Labor force growth, we get a 1.7% reduction in labor force growth. Those two components add up to the 5.7%, okay. We're just simply decomposing that. You might say, well, there could be changes in labor supply. Do you really want to look at output per worker? What about output per hour worked? Okay, particularly if there are intensive margin reductions occurring in the later years. So we can do that as well. Looking at output per hour worked, we get a 3.7% reduction in productivity growth using that measure. And the other side of that is a 2% reduction in labor force growth. Okay, so attenuates, the basic story is the same. The larger component is the effect operating through productivity growth, but a little bit less so when you look at actual output per hour worked rather than output per worker. Okay, so you can also ask, well, what about the value of that labor hour worked? Okay, so we're going to next look at GDP per earnings and earnings per capita, okay, to get a handle on that. So I'm just adding that in the third column here. And here, you see once we adjust for the value of that hour worked, the effect goes away. And this is what you'd expect if there has been a labor market adjustment to the decline in productivity growth over the period. We can do it for GDP per compensation, per dollar compensation as well. So now we're going to say, well, what's not just earnings? What about earnings plus benefits? And there you can see that it's a little bit less, qualitatively the same, but we get a little bit less of an adjustment operating through this channel than for just earnings themselves. So potential explanations for this decline in productivity growth, a slowing in productivity. And so the first thing to recognize is that the estimate reflects changes in the composition of the workforce. It's not necessarily evidence of within individual declines in productivity per se, okay? It doesn't say anything about that at all. potential explanations are many, and here are two. One, older individuals who choose to work may simply produce less. And this could come about if people were sorting into part-time work in their later years, if people were sorting into less demanding positions. There's evidence of this in the retirement micro-literature on retirement behavior, some of that I've looked at myself. This could also come about if there are losses in firm-specific returns to job tenure coming from job changes, okay? So again, it's not saying anything about an individual's own trajectory in their kind of potential productivity, but you can actually see these kinds of effects coming about if there are these changes in the composition of labor supply at older ages coming from the micro level. Two, it could also be the case that the outgoing cohorts of older workers are more productive than the incoming cohorts. Okay? And this could come about through, say, for example, a loss in spillover effects on younger workers. And there's some evidence that, coming from FAIR again, that may indeed be, one way this can come about is through the management channel. I won't say very much about that, but I thought that was a very kind of interesting hypothesis. And another related point, and I think this gets at Gary's work, is that the experience gap between older and younger workers is now relatively much, much larger than the schooling gap. So it used to be that the incoming younger cohort has substantially more human capital, more years of schooling than the outgoing older cohorts. And over the last 3 decades, that's narrowed tremendously, and this just gives you a snapshot of what those trends have looked like this is during our sample period and then taking it out to 2020, just so you can see where it's expected to go. But large gap in schooling in excess of 3 years at the beginning of the period we look at in 1980. And here we're just saying, let's take the year 1980 and compare the years of completed schooling for somebody who's 25 versus somebody 65. So you can imagine that the 65-year-old is being replaced by a 25-year-old on average that looks like this. And you can see that over successive cohorts of 65-year-olds, that difference has really narrowed dramatically. So now we have a situation in which that return to experience, even though the returns to experience are estimated to be smaller than the returns to a year of schooling, when the return to experience is, say, a gap of 40 years, that effect could actually easily swamp these differences in schooling between incoming and outgoing cohorts. So that's one possible explanation. We also looked at the effect of growth in the aging population on all ages. So it's also interesting to think about, well, what's happening to younger workers as the population estate ages? And here we find, we're using the same methodology and looking at growth in employment and employment rates by age, and these are separate models for each age group. And here we find very little evidence of an effect on the employment of younger workers. Nothing is statistically significant, and in fact, all of the effect is concentrated among labor supply reductions in the oldest group. Okay, so that's, I guess, somewhat reassuring that the instrument is indeed operating through the labor supply of the older workers, but also quite interesting. For women, the effects aren't very precise, although qualitatively they're similar. There is, however, an effect of population aging on wage growth for both younger and older workers. And this is consistent with that productivity effect. So if there has been a decline in productivity, the labor market should adjust, earnings should adjust downward, and that's what we would expect to see. And we see an across-the-board reduction on the order of about 4 to 5%, not in the level of earnings, but in the growth rate of earnings in these ages, okay? Same for men as for women, a little bit smaller for women. So, hopefully I'm right on schedule here. The bottom line here is that we're estimating that a 10% increase in the share of the population 60 plus decreases per capita GDP growth by 5.7%. It's an elasticity that divides up into most of the effect coming from a reduction in productivity growth, and we see some evidence of adjustment in the labor market to those effects. And a smaller part coming from a reduction in labor force growth. I didn't show this evidence in the interest of time, but we don't find that that these effects are concentrated or really driven by, say, one particular industry. We see these effects across most industries, although I think there's some interesting differences that we're going to want to dig into further. So, for example, the effect of aging in the service industries has been smaller than its effect in, say, the construction industries. Okay, so there's a lot more to do there that I think will be interesting and help us kind of get some sense of the mechanisms behind these effects. No effect on the employment growth of younger cohorts. It'll be interesting to see if that changes going forward. We'd expect to see perhaps an increase in employment, but it is perhaps heartening to see that there's been no displacement of younger cohorts. And some effect, some small effect on wage growth, really across the board, younger and older. So to try to put this in perspective, these are obviously very precisely estimated effects that seem significant, but how do they compare to, say, the hypothesized effects for the future that the National Academies panel estimated or predicted? And these effects are quite a bit smaller, about a third the size of what that panel predicted. So over, say, a 10-year period, they were predicting a reduction in GDP growth on the order of, say, 33%. So about a 33% reduction in the growth rate. We're coming out at about, if you take our numbers and try to kind of fit them into their framework, ours are elasticities, so we get them by time, 10-year changes over the next decade. Ours are coming out at about 12%. So 12% versus 33%. This could be good news that the effects are less than we thought. It could be evidence that there are some offsetting forces at play. It could also be that we're missing part of the effect here, which is the national level spillovers from having an older population on the federal programs that don't vary at the state level. Okay, so for example, an analysis like this that utilizes variation across states can't really get any purchase on those additional effects. So that, I would say, is kind of the big missing piece at this point is, if those programs in the future lead to increased tax rates, higher debt, those effects coming forward can wind up being quite important and affect GDP and living standards in ways that we would not capture here. To try to get at that a little bit, we're in the process now of doing the same analysis across countries. Okay, there you can actually pick up these national level spillovers as well. Okay, so without further ado, I think I'll stop there and turn it over to Bob.
Okay, so this is I didn't really realize actually until John made the point that there had been a change in title, and I had a lot of my comments really are in reaction to the title that was the paper that I was sent, which is the effect of population growth on economic growth, which is a more ambitious title than the previous title, which was labor force aging. So bear that in mind. So a quick summary of what's done is that they use cross-section variation in age structure from 1980 to 2010 to estimate the effect of aging on output per head, or growth in output per head. And they do a very clever thing, which I think is to use the IV to eliminate possible endogeneity of state age structure due to migration. And so the first stage, the age structure in T minus 10, is used to predict the age structure in T. And they do some other things as well, of kind of sensitivity checks on that. But basically, that's the the scheme that they use, and they find a 10% increase in population over 65 decreases GDP per capita by 5.7%, primarily due to a decrease in the supply of labor. And they find some decrease in productivity, possibly indicating that older cohorts may be more productive than the younger cohorts they're replacing. To someone like me, who didn't belong to the greatest generation, it's nice to know that I might be in a greater generation. But I think that's an interesting thing, and one would want to sort of understand sort of what's underlying that. So what is population aging? Well, in steady state, an older population is the consequence of lower fertility or lower mortality, and the rate of growth of the population is really determined by the net reproduction rate. And so it's really sort of largely a fertility-driven issue as to the overall rate. And given sort of stable fertility and mortality, one can get an older population or a younger population, depending really on what the rate of growth of the overall population is. In the US, our age structure is changing more slowly and less regularly than in other advanced countries. So in some sense, the US is, amongst the advanced countries, is less of a test case for aging than in others. And so I'm encouraged to hear Nicole saying that they're going to go on and look across countries, because I think that may be a sort of more powerful thing. US fertility is actually near replacement. In the post-World War II baby boom has produced an echo, and we have immigration. But if you look overall, you can sort of see what's going on in the US this is between 2010. So where we are now is this bulge that you see here of people entering their 50s, and then we see the aging of the boomers is reflected up here. That's in our future, but on the other hand, if you look at the long run projection of to 2050, what you see is still a pretty pyramidal kind of distribution. Whereas if we were looking at Italy or Japan or many other countries around, what you would see is an hourglass shape or vase shape, where the base is small relative to the size of the rest of the distribution. My comments. So Nicole and her co-authors have devised, I think, a really clever scheme to use variation in past age structure across states to investigate variation in age structures that are similar magnitude to variations in the age structure that we'll face in the first half of this century. And it seems to me their IV approach seems to me to be a valid way to purge the confounding way of compounding effects of immigration. So the estimates basically show that aging causes reduced per capita output because old people are not working. And that's really the biggest effect. So it is this kind of compositional change. And I think that the results really imply that productivity effects of aging could be estimated really using sort of standard growth accounting techniques. So in some sense, it seems to me there's kind of support for the way in which often we measure these things in growth accounting. Put differently, there don't seem to be important spillover externality effects of aging that need special treatment that are arising in this particular example. Now, the kind of thing that really provoked me with the title was that the title is really talking about aging, population aging, and the IV estimates are basically, you could think of them as reduced form estimates from data on 50, and I hear say United States that are in a fiscal union in the past. And the challenges of population aging largely concern the trade-offs that we have in the society between the support of the elderly and making investments in the human and physical capital in the productive power of the economy. And in that sense, in that sense, what the paper is doing, I think, is a very useful, in some ways, validation of relatively standard ways in which one might want to predict the growth of the labor force and its productivity. But they really don't address sort of what the impact of aging is. And actually, the very last item on the very last slide that Nicole raised is really addressing these, what she termed as sort of spillover effects. I guess I would term them really more general equilibrium effects of what's going on in the future in the United States, and in many respects much more dramatically what's going on in much of the rest of the world. So, for example, I was at a conference last March in Hong Kong that was called Aging in Asia, and there the topic of basically pretty much every paper that was presented from a number of different countries in Asia was, what are we going to do? What are we going to do about this booming number of old people in a world in which family care has been the way in which we've cared for older people who are now going to be surviving to ages at which they're going to have high likelihood of dementia. The families that used to care for them now are starting to become geographically more dispersed. The women are working, and we don't even have institutions to deal with that. And so it seems to me, if you're wanting to think about sort of what's going on in these situations, you need to think about, well, how are we going to organize ourselves to care for the elderly? And if we do that, what are the fiscal effects and market effects going to be on other things, like who's going to be teaching the young, who's going to be saving for producing, where are the source of savings for producing physical capital and so forth. So, it seems to me that there's little reason to expect that the estimated reduced form estimates from the 50 states would remain stable as the political and economic aspects of this challenge play out. So I think it's important to recognize that, on the one hand, I think the estimates produced here are really very useful and a very good start on a practical program to understand these things, but I think really understanding population aging involves much more. Just as an example, many of you have seen this striking graph from Ron Lee about the trends in age profiles of consumption from 1960, when you can see basically a hump-shaped profile where people's consumption was maximized in their 60s. In 1981, you started seeing this growth of this top layer, which is really healthcare expenditures, and it grows very rapidly by 2003. Well, the set of public and private transfers that are required to support a consumption profile that looks like that really get challenging when most of the people end up on the right side of the graph, which is what happens when you have population aging. We know something has to give. It just is not possible to run that kind of age profile and keep it unless you made it a lot lower, which would be a bad outcome. So there are a lot of things that are going to have to change. And so my conclusion, and I think it's, I just soon sort of open it up for the general discussion here, is that we've got, on the one hand, a clever IV estimate of effective variations in age distribution and labor productivity, but we need really more discussion on how these estimates would fit into this broader set of challenges. And I would actually be interested in hearing Nicole elaborate a bit more on where she thinks how the international evidence may play into that, because I think it seems to me that has quite a bit of potential for that. So I really enjoyed the paper, and thank you.
yeah, I'll just kind of add, oh, I think I'm still mic'd.
You're still mic'd.
Yeah, I'll just add that, that I do think the international evidence, I mean, I think that the variation across countries is the way to kind of start bringing in these sorts of effects on that are going to be operating on the budgets of countries and affecting GDP, but where you're not getting regional variation to exploit. So, it's during this period that we're looking at, 80 to 2010, we're probably not missing as much as we're going to be missing if we try to do this analysis going forward, and that's why it'll be important to move, I think, to that kind of an approach.
And it's also the case that the units that you're looking at are not like 50 different countries. They're 50 states in a unified, in a union. So a lot of the kinds of fiscal effects that one would see, and we're seeing like in the EU, are not present when you're looking at the U.S.
Let me just mention some anecdotes and then ask the question. We're in the middle of the Nobel Prize season, and what I anecdotally notice is most of the breakthrough ideas were done by people when they were young. Like the chemistry guy that just got it, you just look at it, it was 30 years ago that he did this work, and you just do the arithmetic, and it must have been his dissertation, that kind of thing. And then, so I had a question about like patents per capita. Does that depend on the age structure? Business startups per capita? In other words, I don't know if the standard productivity captures the kind of breakthrough venture capital. I mean, that's what I'm thinking of. The real breakthrough ideas, I tend to think are done by young people, and so I don't know if that's just an anecdote or just a thought, or whether there's any way to test that. That if you have a relatively small group of young people, whether you're going to be short on these breakthrough ideas.
A little bit of that in the National Academy's report, where they assemble some of this data on I think they actually have Nobel Prize winners and over time and average age, et cetera. Actually, the average ages have actually nudged up a little bit, interestingly.
It's not the age of the prize winners, it's the age of when the work was done. Often we recognize people for work that they did.
Yes, I'm sorry.
30 years ago.
I meant that.
Okay.
Can I just respond to your example?
I need a mic.
A Nobel Prize winner.
Well, I think it's a bad example, because to get the prize, your idea has to have had an impact, which takes time, and you have to still be alive. So the wonderful things done by 60-year-olds take time, and damn it, they're dead. And so they don't get a prize. So I think that may not be the best possible example.
So patents, though, might not have that problem.
Yes, I mean, lots of other domains.
Right. Yeah. Daphne, whoever you want to call on.
So I had two questions. One is when you construct your instrument, so you've got a change in 10-year change in GDP on a GDP per capita on a 10-year change in some age composition measure. Are you always using the observed value for the first year, or are you sort of going back to some baseline period and just predicting the whole, the change for each decade off of national changes relative to like some 1940 population structure? Because otherwise that first observation is endogenous. The one at the beginning of the decade is as endogenous as the one at the end of the decade, right?
I see. So you're saying if you started with 1980 and based everything off of
Just apply the national trends for the
Yeah.
whole sample and use that for your idea.
Yeah. I think we start with actual at the base period. So
Right.
we can try that.
The other question was, I think this goes to Bob's point a little bit, was in some sense it was an external validity question in some sense. You go from states to countries, right? It's easy to migrate, of course, by across states in the U.S. I was sort of interested in seeing, and part of the debate is, do we encourage the migration channel? Do we shut down the migration channel? Depending on who you ask. You could actually study the migration response to the exogenous changes in aging and see how big it is and see how much it matters. And that would actually be really useful to know. In Europe, they argue about this a lot.
Yeah, actually, we can, and in fact, I think we've actually, we've got we've made some steps in that direction. Nothing to talk about yet, but good point.
As you go into the national level analyses, or even these, I wonder if you could also explore dynamics. Today's age structure affects future productivity. I think there's this work, for example, by Jim Paterba, looking at the sort of what happens to what governments spend money on as a function of the changes in the age distribution. So most, K through 12 and higher ed. It'd be interesting to see, especially in the cross-country kind of analyses, do we see sort of change? And this is kind of in response to this figure that was just put up with that showed these big changes in sort of public goods provisions by age over time, and to what extent does the age distribution affect investments in future productivity, rather building on today's effects too.
Yeah, that's good.
I'll just do one quick follow-up to Mark's question, because it was partly related. I didn't have his question, but it's related. That your productivity variables right now are missing, I think, the future productivity that people have been talking about. Maybe Gary knows more than this, that productivity growth will be held down by the fact that we're shifting from highly productive industries to less productive industries, even in the private sector. So if we care for the elderly and you shift from whatever you're doing, Facebook, to home health care, that was a joke. If you shift the population to taking care of individuals, then that's a pretty hands-on, low productivity. And John Fernald, my colleague at the Fed, he's done a lot of work on growth accounting and thinking about these types of things for the future. And I just think it's worth considering.
Thank you.
Just putting together a couple of presentations we saw earlier. There's a growing gap in mortality or longevity, inequality, and Mark's work showing lots of people getting out of the workforce with the disability benefits. Is there any evidence that there is a growing productivity inequality, particularly at the older ages, where you've got a group of people that are continuing to be productive and a group of people that aren't? And are these the same people that are experiencing productivity inequality and mortality inequality and income inequality?
Good question. I mean, I think we know quite a bit about it. We can draw some inferences about what's, how these things are taking shape. And, Gary did a really nice job in laying out some of these issues in a recent paper where you have the low SES segments of the labor force selecting out early and into these, disability insurance programs as an example. And so, to the extent that they're lower producing to begin with, it sort of moves productivity up. It's kind of a productivity gain in a way, the way the numbers look at it. But then you can also look at it from, the individual perspective and ask whether it's optimal for that untapped work capacity to be underutilized.
Other questions? Or is lunch calling? Okay, yep. Yeah, I'll take care of it.
Sorry, I don't want to keep everybody from lunch, so I'll be quick. So it's a bit of a non-standard growth accounting framework in that usually you divide things into productivity, labor, and capital. And so one of the things I was wondering is if you have data on capital, if there's different capital labor complementarities or substitutabilities across the age population and across the types of tasks that the aging population are doing in the workforce. Because if not, then it's all showing up in productivity.
So of course it's not in this analysis itself, but you're right, it's all being rolled up into the productivity measure right now. We could look at that. Actually, I might be good to talk to you afterward about some ideas for that. Yeah.
Okay, why don't we break for lunch, and why don't we resume at 1 o'clock as scheduled?